This is my day for having technical issues. 1 second. All right. Yeah, my computer during my first class this morning decided to automatically restart. That was not something I wanted at that moment. So, okay. Every once in a while, you have to have a day of technical issues to keep things real. Or all right, we're gonna do something. Let's try something else. I'm going to go to, I think we've had this happen before. I'm going to go to another course site. We're learning from experience. So you muscle fibers, I think that's where I was. Do you know 1 second here? A muscle fiber is synonymous or a muscle cell. Some other words to keep in mind here. Myo means muscle. Another one, sarco. Means muscle. So muscle fiber, muscle cell, myomuscle, sarcomuscle. With that in mind, you are born with all of the skeletal muscle fibers you will have. So you are born with all of the muscle cells you will have. Most of these cells are going to last a lifetime. Well, how do you get bigger muscles then? For some reason, your muscles don't stay the same from when you're couple hours old until, thankfully, they don't stay the same until you're now 21. Muscle growth occurs by hypertrophy, which means that the muscle increases in size, but not in number. So muscle enlarges by increasing the number of myofibrils. So these are the filaments within the muscle fibers. Testosterone and hypertrophy hormone, human growth hormone stimulate hypertrophy of the muscles. So muscles increasing in size based on the fact that there's more myofilaments being added. Muscles can lose myofilaments and increase in myofilaments. If the muscle atrophies, it loses filaments, myofibrils. If it increases in size, it hypertrophies. Some different properties of muscle. Muscle is excitable, it's responsive to chemical signals, to stretch, to electrical changes along the plasma membrane. To conductivity, local electrical change, just can trigger a wave of excitation that travels along the muscle fiber. Contractility, the muscle can shorten when stimulated. We have two different types of contractions. We have isometric muscle contractions, where the muscle develops tension but does not shorten. Isotonic muscle contractions. Enough tension is generated that the muscle can move an object, and so the muscle shortens. So iso means the same, metric meaning length, isometric meaning stays the same length. Develops tension but doesn't change its length. Isotonic meaning it changes its length, but the tension remains the same. Muscle is extensible. It's capable of being stretched between contractions without being damaged. It's elastic. It returns to its original resting length after being stretched. Which of the following is not a function of skeletal muscle tissue?
Is it A?
Why do you
Would
think
it be
A?
D?
Why do you think it's
Because you need to hold up your head, you need that strength and posture.
why is it? Wait. Caitlin, reread the question. Which of the following is not a function? If you're holding up your head, is that a function of skeletal muscle?
Oh no, because
It is, yeah. If you're moving your eyes from left to right, that's skeletal muscle. Kevin, why do you think it's D?
That's smooth muscle that does that, right?
That's smooth muscle. Right, so the answer is D. How is muscle organized? There are bands of fibrous connective tissue that's deep to the skin that surrounds muscle, keeps muscle fibers bundled together. You have probably seen these when you were cooking your turkey. You've seen the little tiny pieces of connective tissue that you can pull off, like the skin of chicken. So there's also a subcutaneous layer that stores fat and separates the muscle from skin, protecting it from trauma. This fascia lines the body wall and limbs. It holds muscles with similar functions together and allows for the free movement of muscles to be able to slide by one another. It carries nerves, blood vessels, and lymph vessels and fills the spaces between muscles. The fascicles give the meat its characteristic grain. So this bundling of fibers together. Skeletal muscle has a sarcolemma. Do you remember what lemma meant? We talked about a neural lemma and an axal lemma when we talked about the nervous system. What is
Like a
lemma?
covering.
Yeah, it's the plasma membrane. You're right, Claire. It's a covering. It's plasma membrane. So sarco means muscle. So sarcolemma means the plasma membrane of the muscle fiber. Sarcoplasm is the cytoplasm of the muscle fiber. Myofibrils are long cords occupying most of the sarcoplasm of the muscle fiber. Glycogen, stored glucose, polymer of glucose, is the carbohydrate that's used for ATP synthesis. Myoglobin, the red pigment, binds and releases oxygen for ATP production. Myoglobin, if you think hemoglobin, myoglobin is a derivative of hemoglobin that's found specifically in muscle. Hemoglobin binds oxygen and carries it in the blood. Myoglobin binds oxygen and keeps it in the muscle. We'll talk about red versus white muscle fibers. Red fibers tend to have more myoglobin. This is the difference, you guys. We just had Thanksgiving. So this is the difference between dark and white meat. Dark meat has more myoglobin in it. White meat has less. Now the question is why? So we'll get to that. Mitochondria lies in rows and is located close to the contractile muscle proteins that uses ATP during a contraction. So we keep a lot of mitochondria around in the muscle because we go through it so fast. It's not something you can store. And so we've got to, we keep it around. We keep a lot of mitochondria around. sarcoplasmic reticulum is a specialized smooth ER, smooth endoplasmic reticulum, that forms a network around each myofibril. It contains terminal cisternae, so these dilated end sacs of the sarcoplasmic reticulum. Terminal cisternae, looking here. Here, the blue here is the sarcoplasmic reticulum. The terminal cisternae are the ends. Sarcoplasmic reticulum is a specialized smooth ER that acts as a calcium reservoir and releases calcium through channels to activate contraction. There's transverse tubules, T-tubules, tubular foldings of the sarcolemma. These are indentations that move into the muscle fiber, which allow action potential to travel and spread throughout the fiber. These T-tubules with the terminal cisternae are termed as a triad. So these are your T-tubules, and they move into the fiber. Here's the fiber, they move into the fiber. That's going to be important later. Myofibrils are contractile organelles of smooth muscle. They contain thin and thick myofilaments arranged in units called sarcomeres. The striations make the entire skeletal muscle fiber appear to look striped. The thick filaments look darker, the thin filaments are lighter. Here's the darker, the thick filament. Here's the thin filaments. Here's the thick filaments. Here's the thin filaments. So the muscle overall looks striated, light, light, dark, light, dark. So sarcomeres are the functional structures of muscle. They're compartments of arranged thin and thick filaments, which extend from one Z disc, one end, to the next. Here's your thin filaments. Here's your thick filament. Here's your light bands. Here's your dark bands. The light bands are only composed of thin filaments. Your Z discs are in the center of each of the light bands, which are called I bands. I as in India, I bands. Which structure releases calcium to trigger muscle contraction? Or which structure stores it?
The SR?
Yep, the sarcoplasmic reticulum, right. Why does calcium have to be actively transported back in? You guys, why does anything have to be actively transported?
Is it because they're going through channels,
Well,
like
you know,
chemically
we have
gated channels?
we have facilitated diffusion, which isn't active transport, but it requires channels. What else?
Is it a situation where it's higher on the outside more than it is the inside?
Yes, it has to do with the fact that we've got to move things against a concentration gradient. And so we're going to find that we're going to think back on this question later. We're moving things against the concentration gradient. We eventually, when the concentration inside the sarcoplasmic reticulum is higher than it is on the outside of the sarcoplasmic reticulum, we're going to have to start pumping it against it, the gradient, because this is where we need it to be, and we need it to be sequestered in there. There's 3 types of muscle proteins that comprise myofibrils. Contractile proteins, which cause the muscle to shorten when they interact with one another. So myosin and actin. Regulatory proteins that regulate the interactions between the contractile proteins, the myosin and actin, which are troponin and tropomyosin. And structural proteins, which keep filaments in proper alignment, giving myofibrils their elasticity and linking myofibrils to sarcolemma. Different ones are titin, alpha-actinin, myomesin, nebulin, and dystrophin. Myofibrils, one myofibril right here. We continue this way, continue this way. Myofibrils are protein bundles of protein myofilaments. Remember, the myofilaments are the myosin and the actin, the contractile proteins, within a muscle fiber that fill up most of the sarcoplasm. Remember, the sarcoplasm is the cytoplasm. They are surrounded by sarcoplasmic reticulum and mitochondria. Their striated appearance is due to the orderly overlap of thick and thin filaments. Here's your thin filaments, here's your thick filaments. Here's your thin filaments, here's your thick filaments. Actually, no, here's your thick filaments, here's your thin filaments. The thick myofilaments are made of hundreds of myosin molecules. Each molecule is shaped like a golf club. There's 2 chains intertwined to form the shallow-like tail, the shaft-like tail. And then there's a double globular head, which is going to bind to the actin. The heads are directed outward in a helical array around the bundle. This myosin acts as a motor protein through its conversion of ATP, potential energy, to motion, kinetic energy. The thin myofilaments are actin. These thin intertwined filaments are strings of globular actin subunits. And each of these subunits has an active site that can bind to the head of the myosin. In relaxed muscle, this site is blocked by tropomyosin. So we have these intertwined, the red here, intertwined actin molecules. And then wrapped around these intertwined actin molecules is this troponin-tropomyosin complex. Remember that this troponin-tropomyosin on the previous slide, it's a regulatory protein. So these regulatory proteins act like switches that determine when a muscle can or cannot contract. Contraction is activated by the release of calcium into the sarcoplasm. And it's binding to troponin. So calcium binds to troponin. When calcium binds to troponin, because it's attached, the troponin's bound to this tropomyosin. The tropomyosin, when calcium binds to the troponin shifts structure, changes structure. It shifts. And when it shifts, because it's attached to the tropomyosin shifts too. Remember what the tropomyosin is guarding. It's guarding the active sites on actin. So when the tropomyosin moves, the active sites are exposed. And that's when myosin can bind to the actin. A structural protein, Titan. Titan got its name because remember that Titan was a Greek god known for his strength. My niece has a pit bull named Titan. This is a big, thick, strong protein that runs through the core of the thick filaments and binds the thick filament to the Z discs, which are from one Z disc to the next Z disc is a sarcomere. So each sarcomere is made of overlapping thin filaments and thick filaments. And the titin runs through the core of the thick filament and attaches it to the Z disc. The M line is the middle, or the M line is the middle of the thick filament. I-bands are just, I-bands are just actin. If you think, one way to think about, and they stain light. They're light in color. A-bands are dark. One way that I had a student bring it up one time, it works. Mnemonic for remembering. The light bands, the word light has an I in it. The I bands are light. Dark bands, the word dark has an A in it. So the A bands are the dark bands when we look at the striations. The M line goes right down the A band. Where there's no overlap between the thin filaments and the thick filaments is the H band. The whole length of the thick filament is the A band. Where there is only the thin filaments, the actin, that's the I band. Right here to right here. Keep this in mind. Over the weekend, spend time looking at that and making sure you know it, because it's going to be important later. A band is just the thick filament. I bands are just the thin filaments. Can you, if you look here, the A band is a component of the actin and the myosin. I don't know if I just said the A band was just the myosin. It's not. It's the overlap. It's where you see the A band. So the Z disc is made up mostly of a protein called alpha-actinin. Remember, alpha-actinin was one of those structural proteins. The M line is made up of accessory proteins like myomycin, C proteins, creatinine kinase, which we'll talk about later, that are all connected to titin. I like to think of the M line as being the middle line through the thick filament. Another structural protein, nebulin, is a protein that wraps around the entire thin filament and helps anchor the thin filaments to the Z disc. Here's the Z disc. Another structural protein, which if you've ever met someone with muscular dystrophy, you understand the significance of this protein. Clinically, it's the most important non-contractile protein of muscle contraction. It links actin, the thin filaments, in the outermost myofilaments of a fiber to the membrane proteins that are linked to the endomysium. Endomysium meaning the outer cover around a muscle fiber. It transfers the forces of contraction, of muscle contraction, to the above connective tissues. The Duchenne's muscular dystrophy occurs when the gene that encodes dystrophin is mutated. Without dystrophin, which remember, it's attaching the thin filaments to the plasma membranes of the muscle fibers. Without the dystrophin protein that has a reinforcing effect and helps maintain the structure of the muscle fibers, the sarcolemma easily tears during muscle contraction. And as a result, the muscle fibers rupture easily and die. Remember, you're born with all of the ones you're going to have. Questions so far? So the striations are alternating A bands and I bands. A, remember, means dark. I bands meaning light. Approximately 10,000 sarcomeres bounded together spans the length of a muscle fiber and gives the appearance of the striations. The sarcomeres are going to extend from one Z disc to the next Z disc and are the contractile functional unit of the myofibril. They provide, these Z discs are what are going to provide the anchorage for thick filaments and tighten. A band stands for anisotropic, which is indicative of the way the bands reflect polarized light. This is where the thick filaments overlap with the thin filaments. The H zone is not as dark and it's in the middle of the A band. And that's where the thick filaments are by themselves without any thin filaments. The M line is the middle of the H zone. I bands contain thin filaments and no thick filaments. And the Z discs bisect these I bands. Be patient with me for one more second here and we'll be done for today. Muscle, this is just some summary slides. Read through these. Fascicle, a muscle fiber, a myofibril, sarcomere, myofilaments. Muscle never contracts unless it's stimulated by a nerve. If the nerve connections are severed or poisoned, the muscle is paralyzed. Denervation atrophy is where we get the shrinkage of the muscle because the nerve remains disconnected. Somatic motor neurons, so voluntary motor neurons, innervate skeletal muscle fibers. And wherever the nerve is in contact with the muscle, we call it the neuromuscular junction. Do you have questions for me? I think this is a great place to stop before we move into the next part. So let's end right here. Have a wonderful day.
Thank you.
You too. Thanks. Bye-bye.
Thanks.
Professor Gessler, I just have one question for you.
Yep, go for it.
When is our last class with you?
What, next Friday?
Okay.
No, not next Friday, next Thursday. I thought that.
Okay, next Thursday. Okay. All right. Well, thank you.
You're welcome.
Hey, I just wanted to let you know I had to take my mom to a doctor's appointment this morning, so I was in this class
You're
today.
fine. I understand. And Erin, it doesn't matter to me which class you come to.
Okay. All right. I just figured I'd let you know I was here today.
Okay. I didn't even think about it, in all honesty. Don't
Okay.
worry about it.
All right. Thanks.
Alexa, are you there?
Yeah, I was waiting. I had a question.
Yeah, why don't I have any scores for you?
Yeah, I got on like the grades and it said 0 and I was confused.
Do you have, you're really kind of quiet, but I'm gonna try to hear. Do you have screenshots showing you've completed these?
The McGraw stuff.
I'm sorry, can you say it a little louder?
Do you mean the McGraw stuff?
Yes.
I can try to get screenshots, but I know I have it all turned in.
But
Well,
you know
most
what,
of it.
if you look at your grades, Alexa, if you look at your grades, they did not transfer over to D2L.
Yeah, I don't know how that works.
And bear with me here. I'm getting a lot of echo here. If you look. Stop sharing for a second. Can you go in, can you actually go into your grades on D2L and share your screen with me?
Yeah. Once I find it. Is it working?
I think it is. Go to, do you see what I'm looking at here? You see the grades on there?
No.
All right, go share your screen again. Do you see where it shows grades?
Mm-hmm.
You see how they all say 0?
Yeah, I don't know why it says that.
Well, that's why that's what mine says too. And so I'm trying to understand where your work is going. Have you seen your grades in Connect?
I've seen like when I turn them in the grade I got, but I haven't looked if
Can
they
you
show them
send
all
me
there.
a screenshot of that? Because right now I don't have any grades for you. Do you understand what I'm concerned about?
Yeah, because I know I do the work. I just don't know why it's not putting me any credit.
And I don't know either.
All right, I'll try to figure out that and then email it to you.
Well, let me also try. I'm gonna look somewhere else. Because yeah, when I saw, why aren't you even in this course list? When you went into McGraw-Hill at the very beginning of the semester, did you actually link with this class? You
I
remember?
thought I did.
Because your name isn't even on that list, and that's what I guess. Bear with me just for a second here. I'm going to call McGraw-Hill while do you have a minute to just be here with me?
Yeah.
Okay, I'm going to call McGraw-Hill because I'm not sure what's occurred. 1 second here.
Thank you for calling McGraw-Hill. To ensure we are providing exceptional service, this call may be recorded. If you are a Barnes & Noble or Follett bookstore employee, press 1. If you are a student, press 2. All others, press 3. Please select from one of the following 5 options. To place an order, to pay for an order you already placed, or to check price and product availability, press 1. To request a copy of an invoice, press 2. If you are having issues with your access code not working, unable to view course materials, have missing assignments, or other issues with an ebook or online product, press 3. To check the status of an existing order, press 4.
I'm going to have to start over. I apologize. I think I clicked the wrong one.
May be recorded. If you are a Barnes & Noble or Follett bookstore employee, press 1. If you are a student, press 2. All others, press 3. Please select from one of the following 5 options. To place an order, to pay for an order you already placed, or to check price and product availability, press 1. To request a copy of an invoice, press 2. If you are having issues with your access code not working, unable to view course materials, have missing assignments, or other issues with an ebook or online product, press 3. To check the status of an existing order, press 4. For all other inquiries, press 5. I have a record tied to your phone number for Mary Gessel. Is this correct?
Yes.
Great. Let me transfer you to an agent who can help.
Thank you for calling McGraw-Hill. This is Aileen. How can I help you today?
You said your name was 80?
That's AILEEN.
I'm sorry, Ailey. My name is Mary Gessel, and I'm an adjunct professor with Harrisburg Area Community College. And I have a student here where it's an online course, but we're both here and present in this online virtual meeting. And she is supposed to be in a class. She's been doing the assignments, but for some reason, her name is not showing up on the roster.
Okay.
Do you have any idea what might be going on here?
Yeah, okay. So before we proceed, can I have your email address for verification
Yes,
purposes?
it's GESSMARY at ISU.edu.
Is it the same with MGESSEL at
Yes.
CRROLLCC? Yeah. Okay.
Um,
And your best contact
no,
number
no,
is
actually, it's not. It's not, ma'am. I'm an adjunct. I
Okay.
teach for 3 schools. And so
Okay.
this school, yes, that is one of my emails. But this
Okay.
school is actually a different school.
Can I have the email address, the alternative email address?
At the school that I'm working with, both of those are my email addresses. But the one that the school that I'm working with right now that I have this student with is MC Gessel, GESSEL at HACC.edu.
Okay. Thank you for that information. Just one moment. So I'll create a case for your concern. I believe this is regarding with your Connect account. Is that correct?
It is.
Mm-hmm.
It's kind
So
of
the
with,
name of your student is not in the list
yes, but she's
when
getting
doing
all,
their
well,
assignment.
she's getting all the assignments. She's just not on the roster.
Okay. So kindly take note of this case number. I'll transfer the call. So you can provide this case number
Okay, give
to
me,
the
I'm
next
sorry.
agent that will assist you.
I need to grab a pen. Give me one moment here.
Okay.
What's the phone number?
So the case number is 226-197-94.
Thank you.
Okay, kindly give me a minute or two. I'll transfer the call right now.
Thank you.
Thank you and have a good day.
You too. Alexa, I think we're getting somewhere.
All right, and I just got on McGraw and I am registered in your class, and I have all my grades.
Well,
and
and
stuff.
that's where I'm just wondering if something is wrong. So there's some link that isn't right where you're not on any of my McGraw Hill Connect rosters. Do you see that I'm looking at all of them?
Yeah.
That you're not
don't
on
know.
any of them. And that's
are you
what
able to-
it's been it's been a little odd, and I apologize for not looking into this earlier. But
that's okay.
when you emailed me last night, I thought, oh, this is that student. So I'm, yeah, and I could never, it takes me a while to figure out which class you're in because you're not on any of these rosters.
Yeah. Are you able to see what I'm showing?
Give me 1 second. Yeah,
You can see like I'm signed in, and
but
here's
you
all
know
the
what?
grades.
You're in the other course. Do you notice that?
Thank you for calling for a tech support of McGraw Hill. My name is Justin. With whom I will pleasure speaking.
Hi, Justin. My name is Mary Gessel. And hi, nice to meet you. I'm an adjunct professor with, and I'm here with, in a virtual meeting with a student. And she is getting all of the assignments that I'm putting through McGraw Hill Connect. However, she's not on any of my class rosters. She should be in one. She's getting all the assignments, and she's been doing the work all semester. She's showing me the scores right now as we share screens. But she is not on the roster. Do you have any idea what might have happened?
There's a couple possibilities. It could be under a different email. have made a separate username by accident.
Let me ask her, Alexa, did you log in through, when you linked into McGraw-Hill Connect, did you go in through your hack email?
I think so.
Let's
It
take a
lets
look
me
at
log
the
out. I can look.
Okay.
on the back end. What is, or let's look you up by your first and last name. For some reason, it didn't pull up. So it's Mary, and then how do you spell your last name?
Gessel, Gessel.
Yeah, I am. My hack.
Okay.
Where are you calling from today?
Say it again. My phone number, it's 952-201.
What school?
Oh, this one is for Harrisburg Area Community College.
Okay, and then what's the email address for the account?
The email for this account, I have, it's different. I have one account, one email that I'm registered for. And then I have multiple emails for different schools. Is that going to be an issue?
I mean, I can look up the other one.
Let me give you the one that I'm registered with that is GESSMARY at ISU.edu.
That is the one I have on file.
Okay.
What is the course and section?
She should be in Biology 121, 504. But what she's showing me, her screenshot is actually for another course. It's Biology 121, 408.
And what's the student's name?
Her name is Alexa, EALEXIA Keiter, KEITER.
That's ELAXIAKEIPER.
Correct.
Okay.
Alexa, shift your screen over a little bit. Yeah, like that. And then try to keep it as
No, I see 60 for it.
Can you go back to where your grades were?
Yeah.
I will say what,
Okay, now can you zoom in a little bit? Yeah, she is actually showing that she's under a different class, but she's not even in that roster. She's her grades that she's showing me right now are under Biology Bio 121 408, which is another course that I teach.
All right, yeah, I found them here. There's that one. And they need to be in the other class.
Yes, she needs to be another class. But if it's going to mess up her grades so that she has to redo all this work, we can keep her in this class. This semester is over in a week. Is it going to do that to her? Because if it's going to do that to her, we need to figure out another way around this.
So I can send a request to see if they can put the student into the other course.
I don't even know how.
Generally, we cannot.
The problem is, and what I'm wondering is, why isn't she even on that roster in that class on my Connect site? She's not even, when I look at my screen, she's not even in that class.
So here's what it looks like. When I pull up the roster,
Yeah.
there's
an Alexander Keiter in one of that class. I'm sorry, go ahead.
You're fine. Yeah, that's ALEXIA.
Yeah, yes,
Keiter, KEITER.
yes. There, okay, there she is. She's right there. She's in that class. Okay, I see it.
Right. Now, when I look to the right, though, past license, past manage,
Yeah,
there's no single sign-on.
but
indicator.
she's done all the assignments.
Right. So what I'm gathering is what this means is that the student registered for the course directly through Connect and not through Brightspace, and then registered for this course by accident instead of the other one.
Okay, so say it one more time a little louder.
Oh yeah. So what it looks like is the student had registered for the course not through Brightspace, but actually just directly through Connect, and then registered for the wrong course.
Okay, all right. Let me, but if switching her over into that course deletes all her work, I don't really want to do that at this point. That's
Okay.
big,
So
yeah,
where we're at, with you only having a week left of the semester, if they can do it, I don't have a definite answer as to how long it will take to do that.
okay,
It could take a week or over a week. If you're fine keeping them in this class and working around it on your end,
yeah.
I would actually suggest just doing that just because of how far along we are. in the
I think
semester.
we'll do that. I think we'll do that. All
Okay.
right.
Okay. Yeah, I'm sorry about that.
No,
I generally would say yes. Let's go ahead and send it over to engineering to see what they say, but I don't know what their caseload is like, and I would hate for us to be in limbo waiting for that to happen up until the very, very end.
right. And I don't want, you know, she's been in this class all semester. I don't want, it's a lot of work to have to realize that's a lot. Yeah, Justin, I really appreciate it. Have a wonderful day, okay?
You as well. Do you want a case number for this by chance?
I already, I don't think I need one. I don't think I need one.
Okay.
Have
Well,
a,
if there's nothing else I can help you with, have a great day.
have happy holidays, okay?
You as well. Bye-bye.
Thank you. Bye-bye. Do you see, so I'm gonna have you share your screen with me one more time. So what he says, what he's saying is that you registered directly, when you registered for the course. Mom, can you turn off your phone? When you registered for your course, you registered directly through McGraw-Hill rather than through Brightspace. And when you did that, you accidentally registered for the wrong course. And it's not that big of a deal. And now that I'm seeing all your scores, it's not that big of a deal. But you see all your grades right there.
Mm-hmm.
You can, I need you to send me screenshots of all of your grades.
Okay. There's just a couple that I didn't finish yet, like the one quiz.
That's fine. Send me in an email, send me which ones and how long do I need to extend them out, because at least I know what course you're in now. But send me all of your grades so
Okay,
that I
and
can transfer them into D2L. What I need on it is I need the title of the assignment and the score. So the title that's over here on the left and the score that's over here on the right.
all right, and then just one more question.
Go.
In my email, it was exam 2 right here.
Yeah.
Would you be able to open that again?
I will, now that I know which class you're in, I will, I'll do it through the 15th, okay, of December.
All right,
But
thank you.
what I need you to do is, we're gonna have to do this for every assignment. Does that make sense?
Yeah, I'm okay with that.
Yeah, I'm okay with it too. I'm sorry we didn't catch this before now. I feel bad about that. But at least we know where your scores are. Just send me a screenshot of every single grade.
Okay, I will.
You can, I mean, it's like this picture right here. Send this to me just the way it is.
Okay.
All right, Alexa, have a wonderful day, and I will extend that out for you until the 15th, okay?
Yep. Thank you very much.
Oh, Alexa, I'm glad we figured it out. And I thought you said you were going to work on it by yourself. I thought, you know what? I can probably figure it out a lot faster. Let me
Yeah,
Alright.
you did definitely.
have a wonderful day, okay?
Thank you. You too.
Welcome. Bye-bye.
Bye.